Dear viewers, this is for the simulation for the PV and wind based hybrid standalone system with battery, right? So conceptually, that is this is the PV source. This operation already you are seeing in the PV source MPPT simulation, perturb and observe method, which is the simulation I think you are received in earlier in the link. And also I am also explaining how the wind turbine driven PMSG, permanent magnet synchronous generator, already we are seeing this simulation. So we are going to connect this PV, photovoltaic array output, and wind power generation output in the DC side. So we want to maintain the voltage on the DC side for the DC grid operation, as like the microgrid operation. We are utilizing one small buck converter. So this is a very simple basic buck converter operation. So this is the one of the power electronic switch IGBT. This IGBT model we are get from that the MATLAB Simulink library, SimScap, then specialized power system, then power electronics tab. This power electronics tab, we have that the IGBT model which is available. This is the IGBT model with that is snubber resistance, which is available drag and drop here, right? So this is the model we are pasted here. Next one is the input of the module we are going to get from the DC to DC PWM. This DC to DC PWM, the output of the this block is giving the pulse waveform based on the input duty ratio from 0 to 1. So that is the 0 to 1. We are giving that the input of this what is this that is the input to the PWM circuit. This model we are going to derive from the, that is power electronic signals, pulse and signal circuit. This is DC to DC, that is the DC to DC PWM generator. This DC to DC PWM generator, this is the switching frequency and sampling. So 0 means the default setting we are taken into account. This power diode model, same power electronics tab, that is we are going to get that the power diode model. If you want to rotate this model, you can press the Control R. This is that the Control R. This Control R rotate the module inside that MATLAB block. So this is the nonlinear that is the element which is available. For that I am going to put that the capacitance 1000 microfarad, the range of voltage 250, the inductance and other values we are giving as per our requirement, basic manipulations, right? So similarly, that is the another one that is the DC to DC buck converter. Here I am connected. This is the one multiplication block. So this block we are going to obtain from that the math operation. So this math operation, that is the dot product and the product block, divide, multiplication. So all this block which is available. If you need the product, again we have going to take as the product block, right? So this is that the concept of that the DC to DC buck converter. here that is the point, that is the reference voltage, because we are maintaining the constant voltage in that DC side by using this common DC reference. This DC reference is connected here. Again, that is the C, that is the, this is which can be connected by to the one of the open loop slider gain. Again, actually we need one of the DC to DC converter here before entering to that the battery module. However, the battery module, we are fixing the voltage of 320, around 320 plus or minus voltage. So for that purpose, I am also going to fix the 320. So if it is change this the voltage, then the current flow will also change as per that is that our requirement. Okay. So this is the basic concept of that hybrid system. So this is the PV. This entire simulation we are obtained from that the P and O. That is a perturb and observe based method operation. Already the simulation you are seeing, right? Again, that is PMSG with the wind powers and the wind turbine driven PMSG. Already we are seeing separate simulation. So both the modules we are integrated through the DC to DC converter. This DC to DC converter having a simple buck converter. This buck converter having a separate IGBT model and DC to DC PWM generation. This DC to DC PWM generation is driven by the PID controller. So where we are going to obtain this PID control, simply we are please come, that is that control and measurement is there. So this is the n number of options which is that additional components, filters, everything which is available in this session. So different types of that controls which is this is the power measurement, everything is available here. Based on that our requirement, we are going to put our the system, our system in the block, different required block. Okay. So if you need the pulse generation, again that the pulse generation. So the additional measurement, that is the different additional measurement is available. Sometimes if the wave is a pulsed wave, we are utilizing to measure this mean value. This is the mean value. We are utilizing these mean values. So this is the control, everything we are seeing on that another simulations. So what is this? Yes, this is the elements. We are going to get this emblem R and C by in this element area, right? So element, this is the interfacing. If it is the need the SIMSCAP to other, again machine, already we are going to taken from that the machine operations, everything. Excitation, this is something that is for the AC excitation for the alternate power generation. This is the measurement and additional measurement. These type of measurement unit we are utilizing, this power unit and everything we are utilized. So THD also used. This THD operation we are obtained in the power quality analysis processing block. Again, this is pulse and signals. So these pulse and signals we are obtain this DC to DC converter pulse from here, right? Next one is the control and measurement. So that is additional component, sample, hold, discrete and other thing. Filter, if you need the filtering option. So logic, already logic option is available, and measurement, what is the existing unit, the same unity is displayed but is in the different concept. This is the PLL used for finding or synchronization purpose. We are using this PLL, right? So next one thing, that is the conversion of that the sawtooth and the triangular waveforms, everything we are seeing. So that is the transformation. This is not in your part and then syllabus. So this is the commonly used in our system. So in the continuous, So if we are going to use in that 1 by s integrations, that is the PID. So the reference PID we are given, the conventional PID, this is the conventional PID, or if it in the discrete, and the discrete PID we are going to be get. Okay, so this is a get from that continuous or discontinuous status. This is the discontinuous status, but we are utilizing that the continuous status. So another one thing, that is the slider gain. This slider gain we are get from this dashboard. So this is the dashboard working in the 2017B version onwards. Before that, some version also can also support. Other versions cannot support these operations. So this is the another control blocks in the discretization based block. Suppose the discrete PID controller, what we are utilizing here, same discrete PID controller we are going to get. Okay, so this is that the mean value. So where we are going to derive from the block, already I have told, that is the block of that is the measurement, that is the additional measurement, that is the mean. This is the mean block we are obtained from that the that is the from the MATLAB Simulink library. So here simply we are maintain the voltage by changing this slide reference, and then maintain this grid voltage. Depends upon this maintaining the voltage, the current supplied by the battery will also change. As this is this much of the battery, the initial state of charge is, that is 25%, that is 25 ampere hour, that is the 320 volt we are going to consider. Right now I am going to run the simulation. It starts running. So this simulation is a very basic preliminary level for that the thing we have going to utilize for how we are going to that is understand in the basic UG preliminary level. See, please see. So that is that the 3 voltage which is that. Suppose I am also going to changes this the voltage or some other thing. Again it may be going to come reduce. So this point will be changes. Again it may be going to change as per that the requirement. So again this is that the current and the voltage, because the ampere hour we are able to meet for the specific simultaneously. You can see if it is changes that the voltage and other thing, so during that time it may be going to change. So we are going to change that the further operation, again run the simulation, it can be changes. So this is the basic operation of that the hybrid system. This system which can be going to measure the voltage, that is voltage which can be combined with the battery. Actually we need one battery controllers. See, renewable energy, this is solar, wind, and this is that the solar system. Here we are going to obtain drives, and in the source block, this is the source block and the interface element. So this is that the electrical source which is available. So the CCV, that is the current charging block, is additionally added if it is needed for the separate battery charging. But due to version conversion, we are removing the block. See, please see, we want to add one block here. So CCV, constant current and constant that is voltage conversion based on the SOC block we should add, but due to version conversion we are removed that block, right? So this is the basic, very basic, how we are going to connect the two systems by using simple buck converter UG preliminary stage beginners level, right? Okay.